An off-grid PV system explanation. An off-grid PV system is one of the most fascinating and practical applications of renewable energy technology. In many ways, an off-grid PV system is like a self-contained power plant that captures sunlight, converts it into usable electricity, stores it for later use, and ensures that homes, businesses, farms, or even communities can function independently from traditional grid infrastructure. To truly understand the significance of such a system, one must dive deep into its background, its technical aspects, its working mechanism, its benefits and challenges, and its broader role in shaping the future of global energy. Off-grid PV systems are not just about technology, they are about empowerment, sustainability, and providing hope in places where conventional electricity has never reached, or where grid power is unreliable. But what exactly makes up an off-grid PV system? What are its key components, and how do they work together to provide a reliable source of electricity? Let's take a closer look at this innovative technology. Solar panels, also known as photovoltaic panels, are the primary component of an off-grid PV system. These panels are specifically designed to convert solar energy directly into electricity through a process called the photovoltaic effect. One of the main advantages of solar panels is their relatively low maintenance requirements. While some panels may require occasional cleaning to remove dirt or debris that can hinder their efficiency, they have no moving parts that wear out over time. This makes them a durable and long-lasting solution for off-grid power generation. Solar panels typically come with a manufacturer's warranty that can last between 20 to 25 years, ensuring that homeowners or businesses can rely on them for a significant period without major issues. Additionally, modern solar panels are designed to withstand harsh weather conditions, including high winds, heavy snowfall, and extreme temperatures. They are typically made from robust materials, such as tempered glass and aluminum, which ensure that the panels can endure the test of time and continue to generate electricity reliably. However, it is important to note that the actual lifespan of solar panels can vary depending on factors such as the quality of installation, environmental conditions, and the manufacturer's warranty. With proper care and maintenance, some solar panels have been known to last even longer than their warranty period. The next crucial component of an off-grid PV system is the charge controller. A charge controller is a device that regulates the flow of electricity from the solar panel to the battery, ensuring that the battery is charged safely and effectively. One of the primary functions of a charge controller is to prevent overcharging of the battery. Batteries have a specific voltage level beyond which they can be damaged. A charge controller monitors the voltage levels and adjusts the current accordingly, ensuring that the battery remains within its optimal charging range. By preventing overcharging, the charge controller helps to extend the lifespan of the battery and maintain its performance over time. Another important function of a charge controller is to protect the battery from deep discharge. Deep discharge occurs when a battery is drained below a certain voltage level, which can also damage the battery and reduce its overall capacity. The charge controller continuously monitors the battery's state of charge and prevents it from discharging too low. By safeguarding the battery from deep discharge, the charge controller ensures that the off-grid PV system remains reliable and continues to provide a steady supply of electricity. In addition to these protective functions, a charge controller also maximizes the efficiency of the solar panel by ensuring that it operates at its maximum power point. This is the point at which the solar panel generates the maximum amount of electricity for a given amount of sunlight. By tracking the maximum power point, the charge controller ensures that the solar panel operates at peak performance and generates the highest possible amount of electricity. Overall, the charge controller is an essential component of an off-PV system as it ensures that the battery is charged and discharged safely and efficiently, ultimately contributing to the reliability and longevity of the entire system. The heart of an off-grid PV system is the battery, which serves as an energy storage device. Batteries store the electricity generated by the solar panels so that it can be used when there is no sunlight, such as during nighttime or cloudy days. There are various types of batteries that can be used in off-grid PV systems, each with its own advantages and disadvantages. Lead-acid batteries are the most widely used type of battery in off-grid PV systems due to their low cost and reliability. However, they have a shorter lifespan and require regular maintenance. Lithium-ion batteries are another popular choice as they have a longer lifespan, higher energy density, and lower maintenance requirements. but they tend to be more expensive up front. Other types of batteries, such as nickel-cadmium and nickel-iron, are also used in off-grid PV systems. The choice of battery depends on factors such as the size of the system, budget, and the intended use. Batteries play a vital role in ensuring that an off-grid PV system can operate continuously and provide a reliable source of electricity. When sunlight hits the solar panels, they generate direct current, also known as DC. However, many electrical devices such as lights, appliances, and electronics require alternating current, also known as C. Therefore, an inverter is necessary to convert the DC electricity generated by the solar panels to a C for use in off-grid PV systems. Inverters come in various sizes, ranging from small models suitable for individual homes to large industrial-sized inverters for commercial applications. They are essential for ensuring that the electricity generated by the solar panels can be used safely and effectively in off-grid settings. One of the primary functions of an inverter is to convert the direct current DC generated by solar panels into alternating current AC that can be used by various electrical devices. This process is known as inversion and is a fundamental aspect of off-grid power generation. Inverters accomplish this conversion by utilizing electronic components such as transistors and diodes to manipulate the flow of electricity, creating the desired alternating current waveform. In addition to converting the current, inverters also play a crucial role in regulating the voltage and frequency of the electricity produced. Maintaining a consistent voltage and frequency is essential for ensuring that electrical devices operate properly and do not get damaged due to fluctuations in power. Inverters achieve this regulation through sophisticated control algorithms and electronic circuitry, providing a stable and reliable power supply for off-grid users. Moreover, inverters often include features to enhance the overall efficiency and reliability of off-grid PV systems. Some inverters incorporate maximum power point tracking (MPPT) capabilities, which allow them to extract the maximum amount of electricity from solar panels under varying conditions. Others include built-in safety features such as surge protection and isolation, which help to protect the system from damage due to power surges or other electrical disturbances. Overall, inverters are indispensable components of off-grid PV systems, enabling the use of solar energy to power various electrical devices and ensuring a reliable and efficient energy supply for off-grid users. Now, let's discuss the importance of these systems. Off-grid PV systems offer several compelling reasons for their increasing popularity. One of the primary reasons is their ability to provide a sustainable and environmentally friendly source of energy. As the world shifts towards renewable energy sources, off-grid PV systems play a crucial role in reducing dependence on fossil fuels and mitigating the adverse effects of climate change. These systems harness the abundant energy from the sun, which is a clean and renewable resource, and convert it into electricity without producing harmful emissions or waste. By utilizing solar energy, off-grid PV systems help to reduce greenhouse gas emissions and promote a cleaner environment. Another compelling reason for the adoption of off-grid PV systems is their potential for cost savings. While the initial investment in setting up an off-grid PV system may seem substantial, these systems can generate electricity at a significantly lower cost compared to traditional grid-connected systems or fossil fuel-based power generation. Once the system is installed, it requires minimal maintenance, resulting in long-term cost savings for users. Moreover, off-grid PV systems offer greater energy, independence, and reliability. Unlike grid-connected systems, which rely on the distribution network, off-grid PV systems generate and store electricity on-site, providing users with a reliable power source even when the grid is down. This is particularly appealing in areas where grid connectivity is unreliable or expensive to establish. Furthermore, off-grid PV systems have numerous applications, ranging from powering homes and businesses to providing electricity for remote infrastructure, such as telecommunications, towers, and street lighting. Their versatility and scalability make them suitable for a wide range of uses. As technology advances and the cost of solar energy continues to decline, off-grid PV systems are poised to become even more attractive. Their potential for sustainable, reliable, and cost-effective energy production positions them as a game-changing solution for both individual users and communities seeking to harness the power of the sun. And now let's talk about some of the challenges associated with these systems. Despite the numerous advantages of off-grid PV systems, there are also challenges associated with their implementation and usage. One of the primary challenges is the high upfront cost. Installing an off-grid PV system typically requires a significant initial investment compared to connecting to the traditional power grid. The costs involved in purchasing and installing solar panels, batteries, and other components can be substantial, which can be a barrier for individuals or communities with limited financial resources. Another challenge is the need for specialized expertise. Off-grid PV systems are complex and require specialized knowledge and skills for their design, installation, and maintenance. The technical aspects involved in optimizing the system's performance, ensuring proper sizing, and addressing any issues that arise can be daunting for none. Additionally, off-grid PV systems face challenges related to weather variability and climate. The intermittent nature of solar radiation and fluctuations in weather patterns can affect the consistency and reliability of power generation. In regions with limited sunshine or frequent cloud cover, the efficiency of off-grid PV systems may be compromised, leading to potential power shortages. Moreover, off-grid PV systems typically involve storing electricity in batteries, which have their own set of challenges. Batteries require regular maintenance, have a limited lifespan, and can be susceptible to degradation due to factors such as temperature extremes. Finally, regulatory and permitting processes can also pose challenges for off-grid PV systems. In some jurisdictions, there may be complex regulations, permitting requirements, or interconnection procedures that need to be navigated, which can add to the complexity and cost of implementing these systems. Despite these challenges, ongoing technological advancements, government incentives, and growing environmental concerns are driving innovation and improvements in off-grid PV systems. As the technology matures and becomes more accessible, these systems are expected to play an increasingly vital role in providing sustainable and reliable off-grid power solutions. If you like this video, please leave us a like and comment if you have any questions. And don't forget to subscribe for more videos like this in the future.